The targets are, we have to have the EU policy in CO2. We have in Germany, for us, about 9 tons CO2 per every person. In France, only 5 tons, because France has a nuclear energy and Germany not. We tried to get out a figure for the saving possibilities of what we are doing in sun protection. And a special duty was to get the difference between manual system and automatic system. That was one of the most important parts for us. The energy consumption in Germany is about 2,500 terawatt final energy. The primary energy is 3,600 terawatt hours. And you see, industry 30% about, traffic 30%, and housing here also about 30%, consumer and service 16%. That's interesting for Germany. Only, you see, air condition. That's really a low value. In Europe, that's much more. Heating, nearly 70%. Water, refrigerator. The refrigerator is 4.7, air condition 0.2. That's the difference in Germany, because we have in Germany big houses, good windows, so very seldom you will find the air condition in Germany. That's one of the problems we have. In wintertime, every day for heating in Germany, one of those ships, 300,000 tons of oil every day during the heating period from September to January to March. It's a lot of energy we need. So we have the possibility to get an impression of what heating means for Germany. Perhaps we can find those figures also for the total Europe. You know the 4 cases, summer, winter, day and night. That's what we are doing every day. I go with this. You know that. That was for politicians. Old windows in Germany, we have 2.8 U value. And we calculated, excuse me, wrong point, minus 46% transmission of heating energy through the window. Even if we have a new window with 1.3, that's the average of the new windows the last 10 years. Now we have 0.9, but even then we can have a diminution of about 28% of heating energy.
Is that based on the 0.9 or the 1.3? 58%.
It's the window.
The window. That's the window.
Yeah.
That's a window. We checked all kinds of private housing. In Germany we have 3.5 billion square meter private housing. And we checked all from 17th century to today. The windows, the quality of buildings, the direction to the sun, and all. We checked all. Here, that was one of the models: sleeping room, living room. We checked the FC value, nothing, a roller shade, and the shadow closed, and also the delta R, 0, nothing. If you take a roller shade and honeycomb, and if you combine it, we had a delta R from 0.7, and we calculate all steps, but these steps we showed. Our problem is we don't know the administration buildings, and we don't know the commercial buildings. We didn't find any figures. So that what we have to show now is only residential buildings. But you see, we have double houses in Germany, 16%. Normal Reihenhaus, more houses, the middle houses, because they have another energy than the end houses. We calculate it all. You see, 40 million buildings. And the data from every building is in the simulation, in combination with the normal weather we have in Germany. Depending on the building age, the glass and the window area proportion, we can save between 10 to 25%. We have 19 years. There's only heating. In air condition, we have a problem because we don't have air condition. But if this 26 degrees, the law from a European community, we would have a necessity of 30 terawatt hours electricity for the cooling energy only in private housing. We don't do it, but that would be the figure we should have. And in Germany, we produce the electricity with coal. So you need 60 terawatt hours coal. And that's a lot. The total contribution of roller shades, sun protection systems, heating energy, 2,000 tank trucks per day during the winter. That's a lot of energy, and we try to show a figure people can imagine. And 2,000, that's about 20,000 tons oil every day. Excuse me, 60 million tons of CO2 from this, not cooling energy because we don't have it. Yet. The figure in Germany, they sell about 140,000 air conditioned units a year. And we have 44 million households, so that is not a big figure. It's not so much. I hoped on bigger figures, but that doesn't work in this way. The difference between automation and manual systems about 20%. That's what we calculated, because we have to look when people leave the house and when they come back. Especially in winter, sun in Germany goes down like 16:10 and they come back at 18 o'clock. The house is cool. The difference is really, really big. Our goals, we are, as we does it here, we have to communicate, and we have to look to the difference, because we have only about 10%. We have to look at the difference, but maybe that the isolation and the new windows in Germany make this difference. Maybe
the difference is in the air conditioning.
That's including air conditioning? Okay, then it's explained. Another thing, we want to give recommendations for architects, planners, for the dwelling in renovation, but also for new buildings. In Germany, the town gives you, we call it a window. You can build up your house in this window. 10 to 10 meters, that's 40 meters. And if you take an isolation of 20 centimeters for new buildings, and it's law, you lose 8 square meters. Apartment for every store. Like 16 square meters, the same price, more money for the isolation, and 16 square meters lost. That's about 20% higher costs. If you take our products, you open to the house, external protection, internal protection, that's much cheaper and better living quality. The legislative process, That's one of our biggest issues we have to do. Training documents, as we told. Okay.